Okay, so this is how to do problem 21 on the chapter 6 homework of collisions. So the pieces of information that the problem gives you is that the girl is 45 kilograms, the plank that she is standing on is 150 kilograms, and they are standing on a frictionless icy lake. So, and we also know that the girl is traveling 1.5 meters per second to the right. So first of all, let's define some variables. So v GI is the velocity of the girl to the ice. VGP is girl to the plank. And finally, VPI is plank to ice. Okay? So from this whole diagram, we can conclude that the velocity of the girl to the ice is the resulting velocity of the girl to the plank and the plank to the ice. If you think about it, it's like if you're moving 2 meters per second in a car that's moving 2 meters per second towards the ground, you'll obviously be moving faster than 2 meters per second relative to the ground. So the velocity of the girl to the ice is the sum of the velocity of the girl to the plank and the velocity of the plank to the ice. So what we do know for a fact is that the velocity of the girl to the plank is 1.5 meters per second. So we can just replace VGP with 1.5 meters per second plus velocity of plank to the ice. So now we have two unknown variables, and with this equation we will not be able to solve this alone. However, we can use another equation and use the systems of equation to solve for this. So using the conservation of momentum, we know that the mass times velocity, the mass times velocity of the girl to the ice and the mass times velocity of the plank to the ice would always equal 0, because the total momentum of the system is 0, and no matter what happens, the resulting momentum will always equal 0 because of the conservation of momentum. So we know that the mass of the girl times the velocity of the girl to the ice plus the mass of the plank times the velocity of the plank to the ice will always equal 0. Okay, so what we do know is the mass of the girl, 45 kilograms. We don't know the velocity of the girl to the ice. We do know the mass of the plank to the ice, 150 kilograms times 0. So these are our two equations. This is equation 1 and this is equation 2. So what I like to do is plug this VGI into here. So we can rewrite this as 45 kilograms times 1.5 meters per second plus VPI, 0.5 meters per second plus VPI plus 150 kilograms, too little space, times VPI equals 0. So look at that, we only have one unknown variable, and then we can start combining them. So if you just do the math in the calculator, or you can just multiply them yourself if you want, you get the answer of 67.5 kilograms meters per second plus 45 kg VPI plus 150 kg VPI equals 0. And then you can add these two like terms together. So that'll be 67.5 kilograms meters per second plus 195 kilogram VPI equals 0. And then once you substitute more, that'll be 195 kg VPI equals negative 67.5 kg meters per second. And you can divide that in your calculator to find the value of VPI. So once you divide that, VPI equals negative 0.346 meters per second. So now that you know this, this is the answer to part B, because it asks what is the velocity of the plank relative to the ice. Now we can use our first initial equation to get the velocity of the girl to the ice, because now we know this value and we can solve for this value. So just a reminder, reminder, the velocity of the girl to the ice is equal to 1.5 meters per second plus the velocity of the plank to the ice. And now we know the velocity of the plank to the ice, so VGI equals 1.5 meters per second plus negative 0.346 meters per second, because that's the velocity of the plank to the ice. So if you take away the parenthesis and the final answer would approximately be 1.15 meters per second.